So we have a function here, and I'd like to find the length of the arc made by its graph between x equals 1 and x equals 4. Now, I'll be honest with you and say this function is a little contrived. I picked it because the integrand ends up being easy to work with, so we could focus more on how to use the formula rather than messy integration techniques. Although there will be an unusual twist about halfway through. In later lectures, we'll look at some functions that are kind of more common, but where the integrals, as you'll see, quickly become more challenging. So I've got our formula for the arc length here. And the first thing we need to do is find the derivative of this function, which it's not a polynomial with the 1 over x, but the power rule is going to apply. So or f prime of x is x squared over 4 minus 1 over x squared. Right, I went ahead and reduced the 3 and the 12. And that is continuous on the interval from 1 to 4. If our interval had included 0, then we'd have run into some trouble and had to get creative. So let's go to the formula. Right, the formula says the arc length is the integral from 1 to 4 of the square root of 1 plus that derivative, x squared over 4 minus 1 over x squared, quantity squared dx. And hopefully you're seeing how some nice things are going to happen. We've got that x squared on the top and the x squared on the bottom. Right, so if you multiply that out, the integral becomes the integral from 1 to 4 of the square root of 1 plus x to the 4th over 16 minus 1/2 plus 1 over x to the 4th. Now, here's that interesting little twist that I promised you. That expression there, the x to the 4th, 1/2, 1 over x to the 4th, not only, excuse me, let's simplify this first. 1 minus 1/2, that's positive 1/2. Sorry, I left out a step. Now this expression, believe it or not, is a perfect square. That's going to factor to x squared over 4 plus 1 over x squared, quantity squared. Then we got the square root of that and the integral from 1 to 4. So you see what I was saying when I said I picked some numbers carefully in there. The square root and the x squared, they cancel each other. This becomes the integral from 1 to 4 of x squared over 4 plus 1 over x squared. It's almost equal to the original derivative. And of course, we can find an antiderivative of this with no particular trouble using the power rule. This is x to the 3rd over 12 minus 1 over x, and we're going to evaluate that from 1 to 4. All right, so substitute 4 in first, 4 to the 3rd over 12 minus 1/4 minus 1 to the 3rd over 12 minus 1 over 1, which of course will be 1. Now, you could say, well, the 4 to the 3rd is 64. We can reduce that with a 12. But look, if we want to add these fractions together, we're going to need a common denominator, and I can see pretty clearly it's going to be 12. Right? So don't mess with the 12. I want the 12 in the denominator. So I'm going to make this 64 over 12 minus 3 over 12 minus the quantity 1 over 12 minus 12 over 12. Now it's much more straightforward. 64 minus 3 minus 1 plus 12 all over 12. It's a little arithmetic problem. Believe it or not, that whole thing ends up being 6. All right, so just in case you were curious, this is what that function looks like. Despite the formula looking a little complicated, maybe, the graph itself is actually relatively straightforward. So we found the arc length for the left-hand part of the right-hand section. So in the next lecture, and in the next example, we're going to look at a function that looks a whole lot simpler. Parabola, it's a quadratic function, and we'll see how even for something that looks simple, that particular formula that we have here can quickly turn into something really much more complicated.